Hello students, welcome back. Previously we went through the vertex form, not the vertex form, the intercept form, y equals a times x minus r times x minus s, and then did some work associated to h and k values, especially k values. X-intercept r and s are there, and k is -2. Yes, minimum is k, or k is +3. Again, maximum can be minimum or maximum. Either way, those are k values. So that's what we did. Now let's focus upon the next type of problem. This time, instead of the vertex or the minimum maximum, let's look at the y-intercept. Y-intercept is -3. Y-intercept is 7, kind of like that. Okay, how does it work? There goes the vertex equation, and then x-intercept is 1 and -2, so 1, and then this is -2, but nobody writes like this. There you go. And here, the key is a value. What is it? Remember, you'll have to answer this one way or the other in order to go to the final answer. How do we apply y-intercept -3? Well, y-intercept is y-coordinate value when x is 0, so -3 is actually f of 0, which is a times 0 minus 1, 0 plus 2. And that's -3. Therefore, so a times -1 times +2 equals -3. So divide these, and I'm going to get 3/2. Okay, I found a value. Therefore, the equation of this function is x minus 1, x plus 2. You can break out the parentheses and get the general term if you want to, but in any case, here's an equation of the quadratic function. But then again, this is not the answer that we are looking for. We are looking for the vertex. So how do I find out the vertex? Well, here we go. H is the average value of those two x-intercepts, and the k value is y-coordinate there. Remember, if you have graph kind of like this, and then x-intercepts are r and s respectively, then the vertex must be right in the middle here due to symmetry. Therefore, h has to be the average r plus s over 2, and k value is just the x coordinate. I mean, h is x coordinate. K value is just a y coordinate. So plug into the equation of the function x equals to whatever h value, and then you're going to get the k value. Remember all that? Okay, so what is the h value? 1 plus -2 over 2. So that's -1/2. K value, on the other hand, is f of -1/2. So here, x is -1/2. Well, x is -1/2. A value is 3/2, you found out. and that's my k value. Let's see. Negative 27 over 8. That's gotta be the answer. So the vertex, negative 1/2, comma, negative 27/8. That's the vertex. What did I do in my answer key? Yeah. Find out a value from the vertex, from the intercept equation. Find out, and then the vertex h and k value. Yes, everything fits. How about the next problem here? Try it on your own. Well, did you try? Y equals to, well, I use f, so g of x equals to a times x minus r, x minus s, but r here in this case, negative 1/2, so plus 1/2, and negative 7/2 plus 7/2, and there goes my equation. And as usual, the key is the a value. I have to find it out. Okay, y-intercept is 7, so g of 0 is 7, you see. So 8 times 0 plus 1/2, 0 plus 7/2, and that's 7. So 8 times 7/4 equals to 7, so a is 7 over 7/4, so a is 4. Okay, a is 4. 4 x plus, excuse me, a typo, plus 1/2 x plus 7/2. Okay, that's the equation, but that's an equation, not the equation you're looking for. The equation actually is the vertex form, and this is the intercept equation in its completeness. A value is also there, but that's not what you're looking for. As the answer, you're looking for the vertex. So how do you find your vertex? H is r plus s over 2. So this one is negative 1/2 plus negative 7/2 over 2. So that's negative 1 minus 7 over 2. No, over 4, excuse me. After multiplying both numerator and denominator by 2. So negative 8 over 4, so that's negative 2. H is negative 2. And how about k? F of h, no, g of h, I named the function g this time. So g of negative 2, that's what I have to do. So 4 times negative 2 plus, 1/2, negative 2 plus 7/2, and that is, I'll just use calculator, negative 9. So h is negative 2 and k is negative 9, and from there I can find that vertex. vertex is -2, -9. I guess that's it. What do I have here as an answer key? -2, -9. Okay. So we went through some typical example problems associated to the intercept form. But I have to warn you that intercept form is something you study after getting totally and completely comfortable with the vertex form. Because there's much better chance that you're going to see exam problems on vertex form than the intercept form. So study that first, and then if you have some time, go ahead with the intercept form. Let's see, I have just a little bit of time left, so let me tell you just a little bit of theory behind the intercept form. I think I told you that the intercept form is invalid if there's no intercept. And indeed, in some case we have intercept, yeah. Case like this, so that graph cuts through. Case like that, so the graph cuts through, and those are both associated to b squared minus 4ac is positive. And no surprise there. Do you remember the quadratic formula? B squared minus 4ac is inside of the square root. So that square root is well defined, so that we have plus or minus square root. Oh, what am I doing? X is negative b plus or minus square root of b squared minus 4ac over 2a. So plus or minus square root. So generally we have two solutions, plus square root, minus square root, if the square root is well defined. And that's when we have two real roots like this. Now, in this situation or that situation, graph do not touch the x-axis, and that's associated to b squared minus 4ac is less than 0. And that's associated to negative number inside square root, so the x-intercepts are invalid. And that's associated with these kind of pictures. And finally, when b squared minus 4ac is equal to 0, we have touching, so we have only one root. And in that case, that's 0, so we just have this negative b over 2a. That's my solution. So in this kind of situation, we cannot use the intercept form. In this kind of situation, we can force it into intercept form, but we end up with complete square. So it doesn't look pretty, and it's not really practical. Most of those problems associated, as a matter of fact, all the problems we studied here associated to this type. But by the way, in these pictures, you can clearly see by the symmetry that the h value, the x-coordinate of the vertex, is right in the middle of those two x-intercepts, r plus s over 2. You can clearly see the behavior in these pictures. Okay, so much for some theory. And that'll complete the quadratic functions.